Good morning.
Good morning.
How are you guys doing today?
Good.
Super sleepy.
That makes two of us.
Yeah, it's a bit early.
Thanks for being patient. I have another class that was just finishing up. I had a couple of questions to answer. Okay, so let's talk real quick. There's a Black History event tomorrow at noon. If you guys want extra credit, attend it. And if you guys upload a picture of you attending it, it'll be virtual, of course. You'll get extra credit, 5 points extra credit towards your test scores. I am still working on the Canvas shell. And also I'm working on Labster. For some reason, the Labster lab that I wanted to have for you guys today isn't working. So you won't have lab today either. I guess we'll start the labs next week. So by next week, you guys should have your lab textbook. And you should already have downloaded your textbook. So you guys already have your textbook?
Yeah, the PDF online.
Cool. Okay.
Dr.
Yep.
If we went to the other event, I think it was the open mic. Do we get?
Yes, you'll get extra credit points for that as well too.
Were we supposed to take a picture of ourselves or anything too? Because I didn't do any of that. I just attended it.
I actually have a record of all the people that attended that event, so you'll be okay in that.
Okay.
Okay.
I was supposed to get in Zoom, but that day I was feeling so sick and I couldn't stay. But
Okay.
I had that day and everything.
Okay. Yeah. Let's see. Okay. So let's see. So your very first assignment will be going up, or you guys should have, actually, you should already have your quiz to the syllabus. Syllabus quiz should have already gone up. And then your next assignment is actually, it's going to be a reading summary. So I'll write in exactly what I want from you. So what I'd like you guys to do is read chapters 1 and chapters 2. They're both pretty short chapters. And then I'll give you a couple of questions. That'll be basically gonna be used for like a quiz, like an open book quiz, okay? I'll try to get my slides uploaded today for you guys, but it's gonna take me a minute. And like I said, I'm having more troubles with Canvas and integrating Canvas and Labster and those things. So let me see. Can you see it?
Yes.
Okay, good.
Yeah.
Okay, so this is going to be physiology. Like I said, normally it's in some places they're taught together. It kind of makes sense to teach them together. So in terms of this course, again, we're going to be focusing primarily on physiology, which basically is going to be dealing with more so the function of the body and not necessarily those elements of the body. Although you need to be aware of the elements, because otherwise it's kind of, be aware of them, but we're not going to go into detail. So I'm not going to have you memorize all of the different bones and things to that extent. Or you may have to memorize some of the tissues because each of them have a different function, and we want to try to talk about those functional aspects. Okay, so often when we think about anatomy and physiology kind of go hand in hand with each other, right? Because if you don't understand the function, then how can you, if you don't know where the structure is, how can you understand the function that you're necessarily looking at, and vice versa? So often the way our body works, our body is responsible for kind of keeping itself in check, right? So what is the significance of like blood pressure? Anyone?
To check your pulse and the heart rate.
Well, that is the technique. We were checking our pulse and our heart rate, right? So it lets us know whether our heart is beating abnormally fast or abnormally slow, things to that extent. So what are some of the reasons why your heart would go up? That rate or that rate of the pressure goes up.
Excitement, anger,
Excitement, anger,
Any kind of like heart disease?
heart disease, yeah. Any other reasons?
Um,
Anxiety. Yeah, when I get nervous, I'm asking a girl out, I get all worked up and sweaty and my heart's just like, my hands start hurting a little bit, So yeah, so those are all reasons why, right? So what does your body do to kind of regulate? Or does your body regulate? Or do you just, it keeps going until your heart busts? What happens?
You start to breathe faster to kind of be able to help bring it down and regulate it.
Okay, so you start to breathe faster to kind of regulate, right? That's one way. What else? What else would you do? Some people just pass out, and then by them passing out, they go through that whole process. They start breathing and relaxing, and it starts to lower, right? So the thing is that your body is kind of designed to kind of self-regulate, okay? It goes through what we call like homeostasis, and we'll be talking a lot about that through this process. Regulation is a key component of your body, right? Self-regulation is a key component of your body. And if it can't self-regulate, then we often have to go to the use of drugs, okay? So physiology is looking at that aspect of regulation. And we're going to be looking at the components in your body that are responsible for that regulation and how they specifically function, okay? So oops, I got carried away. So there are two types of anatomies, which we're not going to be focusing on. We have what we call gross anatomy, and then we have what we call microscopic anatomy. Gross anatomy is also called macroscopic, macro meaning seen with your eyes or big or, or micro meaning small, microscopic meaning that you need a microscope to sit there and see it. So those are the two different forms of anatomy, right? So again, we're not going to focus too much on it. It'll be very little. And the parts that we will probably be focusing on is that microscopic aspect of it primarily. And then we'll be talking generally, what is the function of your bones? What is the function of this? Okay. So you won't need to know the different details of those different components. And if you do, I'll let you know. Okay. Okay. So the body is, or I should say, the body's kind of organized in a certain fashion. So there's kind of levels of structural organization of the body, right? And just in life in general. So we can kind of apply this all across the board. Any living thing, we can apply this way. So at the very top of this pyramid here, and you probably can't see it well, we have what we call the chemical level, right? So the chemical level is basically made of those atoms, those molecules. So like, for instance, when we talk about atoms, we have like hydrogen, oxygen, carbon, right? So some of those building block chemicals, okay? So, and then we will talk about, so those are the elements, atoms, carbon. So then we can talk about the molecule, right? So one of the major molecules our body and most living things kind of have in them is water, right? Do you guys know how much water your body contains, roughly, percentage-wise?
Is it 60?
It's anywhere between 60 to 75% of your body, right, is going to be water. So water plays a key component in what you have. And I'm horrible at drinking water. So I'm always dehydrated. That explains why I have these huge bags under my eyes and why I don't sleep well and why my pee is really yellow and all those, right? So water is also used highly in terms of self-regulating, right? So what happens, let's say you go out in the cold, right? And you look at the top of somebody's head. What do you typically see? Like if it's freezing cold, like really, really cold outside. Have you guys ever watched a football game and they're in Minnesota in the middle of winter? and one of the guys take off their helmets,
Would it be like beads of water?
you'd actually start seeing a little bit of beads of water, and you'd also start seeing some steam coming up, right?
Oh,
Because
that's right. Oops.
in that context, they're trying to use the water to sit there as, again, to kind of self-regulate, right? To kind of warm up the system, okay? So what happens when you go for a run in the summer?
You sweat.
Sweat. Why do you sweat?
Water.
Again, it's water, but you're sweating to also regulate the body. You don't want the body to get too hot, so you're sweating, okay? So water is a key component in our system, and it's also going to be a key component in the course, because you're going to start seeing how water plays an effect here, particularly in this chapter. Okay, so the next level is the cellular level. This image is a crappy image. I got to get a better image for you guys. So at the cellular level, we're talking particularly about cells, right? So your body is made up of cells. Your tissues are made up of cells. So a lot of these cells are specialized cells, or your tissues are specialized, but the general component of a cell is kind of simple. And we will talk about those components because you guys, I mean, how many of you guys took general bio? You guys know?
I took general bio like a couple of years ago.
Yeah. So we'll see how much of cell biology you guys actually remember. You guys know what the mitochondria is and the organelles, well, your organelles and your, you remember any of that?
Not me.
A little bit, barely.
Barely. Well, you're going to need to know it because it's going to be important. Okay. So we have the cellular level. So then once we get to the cellular level, right, the cells come together to make tissues, right? So your heart is made up of tissue. I mean, your heart is I should say, the heart is made up of tissues, right? And those tissues are made up of cells, okay? So we have what we call the tissue level, okay? So we go from the cellular level to the tissue level, right? And so in that particular organelle, that particular organ, it is consistent of tissue, right? And so like my heart has cardiomuscular tissue, and you'll also have, let's see, anyway, I can think of cardiomuscular tissue. You also have some smooth muscle tissue that is part of that. And that makes up that particular organ. And that would be our next level, is the organ level. And so you know your organs, right? So your eyes, your skin, right?
Yeah.
Okay. So then those organs, they start making systems, right? So we have what we call like the urinary tract system, which is shown here, right? So all of those organs are part of that particular system. And so those systems are going to be used as systems of control. Right? So what do we use the urinary tract system for?
To flush out toxins.
Flush out toxins, right? What else? It also is used for bringing in toxins, you know? Because isn't drinking a component of your urinary tract system?
Yes.
Because it's the inlet, right? So all of these systems have to be regulated in some fashion, okay? And that's going to be essential for your body, right? So, and then the last level is called the organismal level, right? In the case of the human body. We can go beyond that for other things, but that's essentially it, okay? So you want to be familiar with these levels. So we have, what is the first level again?
Chemical.
Next level.
Cellular.
Cellular.
Next level.
Tissue.
The next.
Organ.
After that.
Organ system.
And final.
Organismal.
Organismal. Okay.
Jesus.
I know. Okay, so let's talk a little bit about your different organ systems. Okay. Okay, so we have the integumentary system, that basically is going to be your skin. It's going to be your skin, it's going to be your nails, it's going to be your hair, right? So what is the function of that? Anybody?
To protect like everything inside of you underneath the skin.
That's right. It's primarily for protection, okay? So yeah, we have our nails to scratch up people just in case they, attack us and stuff like that. We have our hair, kind of protect us from the sun so we're not getting our head, burnt off, right? And then we have our skin to kind of keep everything internally protected, So then we have the skeletal system. What is the skeletal system for?
Movement that's aided by the muscular system.
Okay. So movement. What else?
Support.
Support. Yeah. Okay. What about the muscular system?
But it was the exact opposite, kind of.
Is it the exact opposite of the skeletal?
Oh, well, it also to do it helps the body regulate temperature as well, and it's supported by the skeletal system.
Okay. And it's responsible for primarily movement, right? Without muscles, we wouldn't be able to move, right? Nervous system.
It's the one that sends out all those relays that information to your body.
So does it help you with your movement?
Yes, because it kind of wouldn't it send out all those different signals?
That's right. So that's right. So you're sending out tons and tons of signals via your nervous system, right? So you're providing information to the rest of your body. Hey, breathe. Hey, flex. Hey, dodge that ball. Okay. So it's a very key component. And you'll notice that how these systems kind of interact with each other, because the nervous system causes the muscular system to respond, right? And as you said, the skeletal system supports the muscular system, right? And it's needed for movement. So they're all kind of integrated with each other. So we kind of need them all, right? So the endocrine system, what is that for?
Hormones, regulate your hormones.
Yeah. And what are hormones and what do they do? We always talk about them in middle school kids. A bunch of raging hormones.
Doesn't it have to do with your reproduction system?
Some of them have to do with your reproduction system. That's true.
Okay.
I guess also has to do with metabolism, I guess. And
they do have to do with metabolism, right? So a lot of the hormones in your body are responsible for regulations, right? They're the signals that are being sent out to say, hey, this is wrong, or hey, you need to have a baby, or hey, we need to secrete a little more saliva, So hormones are responsible. They play a huge part in terms of regulation of the body. Okay. Cardiovascular system.
bringing blood and oxygen to the heart, to the body.
Yep. So yeah, you're going to need to be bringing blood and oxygen to the heart and the body. So you're saying, let me make sure, because we have the cardiovascular system and we also have the respiratory.
Mm-hmm.
How do they differ from each other? So you said cardiovascular system is bringing blood to the heart, and you said oxygen, right? So how does oxygen get in the blood?
When you inhale and exhale, all those it goes through like a process through gas exchange.
Okay. And what else does the cardiovascular system do? There's another very important thing it does. People don't often think about it, but if you think about a car, you'll think about it. Anybody who works on cars.
makes everything run.
Well, yeah, because everything needs oxygen. So yeah, definitely makes everything run. And we kind of need oxygen to sit there and make energy. So, or to utilize energy. So yeah, okay, I can buy that. Something else, one other thing. So it's running through your body, right? So the blood is actually running all through your body. So one of the reasons why, what is one of the reasons why you think the blood is running all through your body?
Because
For a good function of the organs.
Yeah, so it provides good function for the organs. That's true. So you're providing nutrients and
Protein and
oxygen.
protein.
Yeah. So yeah. So it's used as transport of those good things too. Yes, that's true. Anything else? So one of the other things that it does is it equalizes the temperature of the body, kind of regulates the temperature of the body. So it's used as like antifreeze. Do you guys use antifreeze in your car?
Yes.
What
yes,
happens if you don't put antifreeze in your car?
part may heat up.
It'll overheat.
It'll overheat, and then
No more car.
your car blows up, and then you don't have a car for a while, right? Well, same thing is happening here, right? The blood is serving a couple of purposes, right? It's providing nutrients, it's providing oxygen, and it's also help regulate the temperature. Okay. Okay, so then we have the lymphatic system. Lymphatic system is what?
This protects your body from like foreign invaders like bacteria and stuff like that.
You said protects your body from bacteria?
Pathogens.
Okay, bacteria, pathogens. Okay, I'm buying it. So it's primarily responsible for your immune response. So you're right. It's protecting you against the pathogen, right? So when we talk about the immune response, there are two major types of immune response, right? We have what we call the native and the adaptive. Do you guys know the difference between the two?
Is native what you already have in you? And then I didn't hear the second word was whatever comes in from
Adaptive.
like, what is it?
Adaptive.
Adaptive?
Yep.
Is that what comes from like an outside source?
Not quite.
No.
Yeah, not quite. So both of them are coming internally. Adaptive is like your B cells and your T cells, right? So your B cells and your T cells, they're able to adjust, change to attack a certain pathogen when that pathogen is formed. So like your vaccine stimulates the production of B cells and T cells, okay? The native response is one that's just there. It's like that first line of defense.
Okay.
It basically will just see things that's kind of odd and says, okay, that's odd, attacking it. And it's on constant, right? So those are like your natural killer cells, things like that. And again, we will talk about those things a little bit. We won't get too much into it because that's a whole nother area called immunology, but we're gonna touch on it, okay? So what about the respiratory system? Tell me about the respiratory system.
Transports oxygen to the bloodstream.
Okay, so it supports oxygen to the bloodstream. Anything else?
Or your breathing system.
Breathing system. Okay. So make sure that we get that oxygen in, and it also makes sure that we get rid of the carbon dioxide. What do you breathe out? Anyone? Anyone? We breathe in what?
Breathe in oxygen, you release CO2.
So we breathe in oxygen and release CO2. Why do we breathe in oxygen? On a cellular level, why is it necessary that we have oxygen? What happened?
For the energy, right?
That's right.
ATP.
That's right. So we can produce energy, right? So there's a chemical reaction called cellular respiration, or I should say there's a chemical or a cellular function called cellular respiration. Okay, so we take in oxygen. We have sugar, which is typically glucose, C6, H12, O6. How many of you guys have taken chemistry?
I have.
Nope.
T.
Okay, so what we get is we breathe in oxygen, we eat our sugar, that oxygen is used to kind of break that sugar up, and then we're able to get ATP from that. It's a long process, but the overall picture, this is what happens. Let me be exact here. Okay, so, and I believe 32 ATP at the very end. So that ATP is then used for energy, right? So without oxygen, like you guys said earlier, we can't have energy, right? So it's a necessity for us and for our survival, right? Are there organisms that can live without oxygen or that can live, it's called anaerobically?
Yeah. I think that's plants, right? Or something.
Well, they make oxygen, but they do both cellular respiration and non-cellular respiration. So there are certain bacteria that are capable of doing it. Single cell organisms that are capable of living without oxygen.
Okay.
So let's see, the digestive system, what is that for?
Breaking down the food that we absorb.
Okay, yeah. So it's responsible for breaking down the food, right? And so why does the food need to be broken down?
To give us energy, and so it just doesn't like sit there and
Yep.
block up your stomach.
And what do you think is going to be used in that breaking down?
Energy.
Well, we're going to use energy, yeah. So sometimes we're going to need a little bit of energy. What else? Something really important that makes up, let's say, 60 to 75% of your body.
Water.
Gives you water.
Water, yeah. Water is an essential part of digestion. If you're not drinking enough water, myself, then you're going to have trouble with digestion, right? You're not going to poop as much. You're not going to, you're going to have issues. You're going to get backed up. You're going to gain weight. Those things, because you're not breaking down the food, you're just kind of trying to store as much of it as you can, right? And then you're also trying to do this a lot more so that you make water, right? Because then your body has to try to make what is not present there. Okay? So what about we already talked about the urinary tract system. I think we used that as an example earlier. So what about, well, we already talked about the reproductive systems, right? So, questions, concerns. Oh, what is the reproduction system for?
For your sex hormones. Reproduce.
Sex
To
hormones?
produce,
Production.
It's for reproduction. It's for making babies, right? Or parasites, depending on how you want to look at it.
Yes.
Okay.
Yes.
Okay, so we will be talking about these organ systems and how they are responsible for controlling the body. You're going to be learning some of the terminology. So it's going to be key that you guys pay attention to that terminology. Let's see. Okay, so When we talk about digestion, one of the major things that we're talking about is metabolism, right? So metabolism, there's two aspects of metabolism. One of them is called catabolism, and the other one is called anabolism, okay? So catabolism is basically reactions for building. Anabolism is the reaction for building. Metabolism is the reaction for breaking down, okay? So, but both of these are your metabolic process, okay? So you have catabolism and anabolism, okay? Are you with me?
Yeah.
Okay. So if we're building, right? So building is gonna consume energy, right? So to build things, it takes energy, right? It doesn't happen for free. So it's gonna require energy for that, okay? So catabolism, that's gonna be releasing energy. So in that case, we're gonna have energy available to be used, okay? So cellular respiration, is that catabolism or is that anabolism?
Catabolic?
It's catabolic, that's right, because it's releasing energy that can be used, right? Do you guys see the difference?
Yeah.
And if we look at it, right, remember that chemical equation? What was that chemical equation?
The O2 with the carbon 6, hydrogen, oxygen, CO2.
C6H12O6,
06.
which is glucose, or can be glucose, yields carbon dioxide and water. Plus ATP. ATP is cellular energy, right? It's kind of a way of making cellular energy, okay? So in this case, we're breaking glucose down, right? We're breaking down that sugar that we eat, and then we're making carbon dioxide and water. And then as a result of that, of us breaking those bonds, right? We're able to get energy from that. So in bonds, in chemical bonds, we have the potential to have energy stored in them. Okay. Piece of cake. Sample so far? Really, really sweet cake? Okay. And so physiology deals a lot with metabolism, right? Because we kind of have to understand that. So if, let's say, you're constipated, right? You can't eat anything. You've been constipated for the last week. Are you going to have a lot of energy, first off?
No.
No, right? So no, you're not, right? So in that context, it's going to play a part in terms of that regulation, and that's going to be essential. Let's say you're on a diet, right? And you're in that middle of that cleanse and everything like that. You're just drinking fluid. You're drinking tons and tons and tons of water, right? Because you're in the middle of the cleanse and you're on a diet and you're only allowing yourself, you're only going to eat 1 meal a day, right? So in that case, are you going to be building? Are you going to be building? Are you going to be releasing energy? Or are you going to be?
I wouldn't think you'd release energy if you're only eating 1 time a day. So I would say you'd be building.
So you say we'd be building, yeah, which is going to require energy. So then what happens in that context, you're going to start taking either the fat or the protein from your body, right, as a substitute. So, but you're also breaking things down, right? Is that true?
Yeah.
So your body is going to try to self-regulate in that context, right? So if you're on a diet, it's going to try to self-regulate. If you're not consuming enough food, if you're not bringing in enough things, right? So it's not going to build in that context. More than likely, it's going to be breaking things down, right? And it's going to be breaking things down that we don't want broken down, muscle, right? because it starts with the muscle, then it'll go to the fat, right? And part of that has to do with aspects of physiology and also regulation. And we will be talking about that in great extent. Okay, where are we at? So here we have these marathon runners, right? So think about it. What is happening when they're running? And if they're running well, right? And if they're not running well, what is one of the key components that they have to do during this process?
You have to
of
breathe
running?
correctly.
They have to breathe correctly. What happens if they don't breathe correctly?
They're not getting enough oxygen.
They're not getting enough oxygen. And then what's going to happen to their muscles?
You're gonna get tired fast.
They're going to get tired fast. What else? Let me ask you this. How many of you guys have played a sport? Anybody?
I have.
You have? So did you guys have boot camps at the very beginning
Yeah, like summer, like during summer training.
during the summer, right?
Yeah.
And like you were real lazy this summer and didn't do anything, and then you went to that boot camp, right?
Yeah.
So, and they had you running, you know, and you're running and running and running. What happened that night later on?
Oh, stiff.
I was sore.
Miserable.
You were sore, you were miserable, you were cranky, you were cramping, right?
Mhm.
Right. So because because you're not getting enough oxygen to your organs, your body says, hey, dude, you're not getting enough oxygen, right? So you also start producing lactate. Lactate causes your muscles to cramp. So did you guys ever get those night cramps where your leg locks up and you're like, oh my God, my
Yeah,
muscle,"
right in those calves.
right?
Right in
That-
the calves.
right? So that's one aspect, right? So if they're not breathing correctly, they're setting themselves up for cramping, right? So that means that you're affecting those muscles, right? Also with that run, right? So if you're not running correctly, you could also injure yourself by straining it, pulling it, things like that. So what else is happening to them?
They look like they're sweating.
Yes,
Like they're
I would hope so, right? Because I'm sure it's pretty hot out there, and then also your body's temperature is going up. So your body's trying to cool itself down. You're gonna start sweating, right? So these are all aspects of physiology, right? So that temperature. And as humans, right, we need to be able to adapt, but we also have levels that we can adapt to, right? So we also have to sit there and use our heads in some cases. So like these guys, you know, on the camel, right? I'm sure that they have water with them for one thing, right? They're also covering themselves, their bodies. They're not covering themselves with black linen, they're covering themselves with white linen. Why do you think they're covering themselves with white linen?
Because white reflects the sun and keeps the heat from it.
That is correct, okay? So in this context, we are often adaptive. Our body adapts to some extent, but there are limitations to our body, right? So under extreme heat, we'll do our best to adapt, but there's a point where we have to make sure we have water and protect physically. Under harsh conditions, when it's really cold, low oxygen, right? Our body adapts to some extent, but there are going to be limitations, right? So if you're climbing at the top of Mount Everest, is there going to be a lot of oxygen there? There's going to be less oxygen.
Less oxygen.
And then so you're going to be doing, trying to, you know, catch your breath, right? So your body is adjusting and you're breathing harder and trying to get more oxygen in because there's not as much oxygen there, right? And if we're, you know, maybe a little more out of shape or something like that, that could end up leading us to passing out or dying or anything like that. So in those cases, we have to sit there, take alternative measures to adapt, right? Our body can't maintain that adaptation. Okay, are we good so far?
Yeah.
Yeah.
Good. Okay. Oops, I got carried away. So to kind of understand how this works is there's what we call a negative feedback loop, right? So we have our stimulus, things that kind of get us started. That stimulus causes the sensory to be recognized. Then we'll do a control, and then we'll have the control basically activates the effector. So, and then that effector will either modulate that stimulus. Okay, so we sweat. Okay, so the body recognizes, man, it's really hot. Okay, so I'm sweating to kind of cool off that temperature. So that's a process of the negative feedback. You guys get it? So 4 major parts of it. You first have your stimulus, you have your sensory, you have your control, and you have your effector. Okay, so let's break it down to body temperature. Here are all the components. So it's hot, right? So then our body temperature gets hot. It's hotter than 37 degrees Celsius, which is the temperature, your normal body temperature. So then your nervous cell and your skin and your brain says, God damn, it's hot, right? So then your nerves say, okay, we need to start making some sweat, right? Okay, so then the brain sends the signals out to the sweat glands and say, hey, you need to get to work because otherwise we ain't gonna make it and we're gonna burn up. So then we start making sweat. And so we use that sweat to cool off the body. Okay, so this is an example of a negative feedback loop, right? So let me give you an example of a positive feedback loop. Okay, so childbirth, right? So here, so basically the nerves, they're going to send impulses, and then these impulses are going to be sent to the brain. The brain is then going to stimulate the pituitary gland to basically secrete. It's called oxytocin. Oxytocin then is going to be carried to the bloodstream. Then this guy is going to actually stimulate the contraction, right? So then you're going to start contracting. And then the baby's head is going to be pushed up against the cervical wall, and then it just continues this loop, right? So this guy causes, because that baby pushed up against us initially, it causes all of these events to occur, right? And then, so as a result, we start getting contractions. Those contractions will start pushing the baby as in getting ready to go out, right? During normal childbirth. So if this doesn't happen, let's say you're not secreting this hormone, what's going to happen in that case? Are we going to be able to deliver the baby? Are we going to have contractions? Anyone?
Can you repeat that again, the question?
I said, if we don't have this hormone, let's say we're not able to secrete this hormone, right? The oxytocin, right? If we're not able to produce it, then are we going to be able to have contractions?
No.
Are we going to be able to deliver a baby?
No.
Yeah. Okay. So in that context, or if you're low in the secretion of that, so what would be a result of that? What would you have to do under those circumstances? 2 possibilities. As let's say you're a doctor, what would you recommend? So you know that you're not producing this hormone. This patient is deficient in this hormone.
Would it be a C-section?
You would either do a C-section or you would induce contraction by injecting what? Take a guess. If the patient is not able to produce it themselves because this is a hormone that's being made in your body, what do you think you're going to induce them with?
Would it be that hormone?
It would be that hormone, yeah.
Interesting.
Okay, so we could induce contractions by injecting that hormone in them, right? So a synthetic form of that hormone, we inject it with them, then they're able to go through the contractions. Okay? So do you understand how physiology plays a part in this and understanding how things function?
Yeah.
This wire. So these are the different regions of the body. We're not going to talk about this too much, you know. We're pretty much going to kind of skim over this because, again, we're working on the physiological. See? Actually, we will be making reference to regions of the body, but I will try to kind of explain that in a little detail. But again, we're working on the functional aspects of things and how things play a part in that, more so than where it's located at. Okay, so there's not going to be as much emphasis on location and things like that. You need to be able to identify. Okay, are you with me in that regard? Okay. Okay. So in this context, here's an example. So there, here, around the heart, we have what we call the serous membrane. So this membrane, what do you think this membrane is? What is the function of the membrane?
It's like a fluid.
Fluid? Okay.
And that's like it's like lubricated around the area.
Okay. So it serves as a lubricant and
layer protection.
okay. So yeah, it serves as a form of protection, and it also serves as a lubricant because the heart technically is beating, right? And so, and you don't want it to sit there and be rubbing up against anything else and like shedding its tissue layers. Okay. So in that regard, so you're going to be familiarizing yourself with components sometimes, and we need to think about how they're functioning and the significance of their function. Okay. So, and then we're going to talk about how medicine basically interface, kind of like we were talking about with the delivery of the baby. How could you deliver the baby? There's two ways: traction, right? Or induction. I mean, not contraction, C-section or induction, right? How many of you guys have had children?
I do.
You do? How old are they?
He's 9.
He's 9. Okay. Was he an easy delivery or was he complicated?
I did have to get induced.
You have to get induced?
Yeah.
So what did
my
they
water
induce
heart
you?
broke.
Oh, really? Cool. So did they induce you with the hormone, or did they actually use a drug to induce the production of that?
I remember them injecting me with something. I'm
But
pretty
not
sure
what
it's
it
probably
was.
the hormone.
Okay. Okay. So, and technology is going to play a huge part into, you know, things that we do today. Like, for instance, we showed the X-ray earlier. So in the first image, that basically is a CT scan of the head. And so it kind of helps us understanding what's going on in terms of that individual in their head, right? You know, is there a tumor there or things like that? So we're going to be looking at that aspect and seeing how technology plays a part in understanding how things are functioning, how well they're functioning. Okay. Are there any questions?
Nope.
No.
Okay. So my slides will be available. The next set of slides will have all the text with it. You know, this one is a rush job. So, but the next one will be more detailed. So you'll have them in advance as well too. So next slides that we'll be talking about is chapter 2. So make sure that you guys are reading chapters 1 and chapters 2. And then, like I said, I'll have a little quiz for you.
Oh, and when will that assignment be up that you were talking about, like a chapter summary?
Yes, the chapter summary will be up. And so the chapter summary basically tells you the chapters that you need to read. And there's also going to be a quiz. So
And that's usually due like the next following Friday?
it is going to be due the next Friday. Yes. So,
Okay.
and that's the way your homeworks are simply.
Okay, sounds good. Thank
Okay.
you.
Okay, no problem.
Can
Not
I
this
ask-
Friday, the next Friday. Yes?
Could I ask a silly question? If we wanted to come back for the afternoon lecture, would we be able to do that too, just to kind of write down more notes that we felt like we might have missed in that first one? Or is it just like a one
you
one
can-
shot a day?
You can come as many times as you want.
Okay. I don't want to sound too eager, but I want to make sure I'm not like missing anything.
And this is going to be posted on Canvas, right? The recording?
Yeah, so a recording will be posted on.
That's right.
Yeah,
Gotcha.
but you have to give us at least a day because it takes a little bit of time to get the recording sent. And depending on how long you stay over.
Okay.
Okay, are there any questions?
Nope.
No.
Well, I'm gonna take advantage of the fact that, I'll flip chapter 2. Give me a second. Okay, so we're gonna start off at the chemical level. Okay, so this is human DNA. This is a model of human DNA. This represents the double helix. So DNA is basically composed of 4 different elements. So you have carbon, hydrogen, oxygen, and nitrogen. And so I'll show you what a DNA molecule looks like here in a second, or a nucleotide looks like here chemically here in a second, so you guys have an idea. But basically, your body is made up of elements, right? So this here is basically the percentage of each element in your body. So these are the most abundant elements, and these are what we call trace elements. So oxygen is the most abundant element. Then you have carbon, then we have hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chloride, magnesium. And all of these guys down here, these guys are trace elements: your boron, your chromium, your cobalt, your copper, your fluoride. Are you guys familiar with the different chemicals and the chemicals?
Yeah.
No.
Okay. So some of you guys are and some of you guys aren't. Perfect. So let's talk about that real quick. And I'll actually include a PDF of the periodic table. So this is P table. There should be a link in the syllabus for you. These are all of the different elements that are currently known. So the letter here, it's usually 1 or 2 letters. Always, if it's 1 letter, it's always that capital. They're always going to represent it as capital. And then that symbolizes this particular element. So in this case, H stands for hydrogen, O stands for oxygen, N stands for nitrogen, P stands for carbon. So those are the ones that are going to be most abundant for us, right? Since we're talking about living things, those are going to be the most abundant ones that you're going to see in the system. Okay. So when we talk about, for instance, H2O, this here represents what we call the subscript. Because subscripts tells me how many hydrogens I have in this compound. And if there's no number here, it's assumed to be 1. Okay, so we have 2 hydrogens and 1 oxygen. That's what makes water. Water is made up of 2 hydrogens and 1 oxygen. What about CO2?
Carbon and 2 oxygen.
1 carbon and 2 oxygens. So what if I do something like this? This compound here is called sulfate. We're going to make it, let's see, Here we go. Okay, so, oops, can you guys see that? Let me move it so you guys.
Kind of.
Okay, so it's Al2, SO4, 3 outside. Okay, so real quick, Al stands for what? Look on the periodic table.
Aluminum.
Can you find it?
It's aluminum.
It's aluminum. Okay. S stands for
Sulfur,
sulfur, and O,
oxygen,
Oxygen.
oxygen. Excellent. So this says that I have 2 aluminums in this compound. How many sulfurs do I have here? Now this is
One.
a 3 out of here. So normally, if I just had this guy by itself and I didn't have parentheses 3, it would be 1. But since I have parentheses 3, that means that I have 3 sulfurs and I have 12 oxygens. Okay. Did you get that?
Yes, sir.
Where's the 3?
You don't see the 3 outside? Let me move it so it's a little clearer. My handwriting is horrible. It's like a 3rd grader, so I'll be able to recognize that it's a 3.
Oh,
You see it
Oh,
now?
okay.
yeah, I see.
Okay. So that parentheses mean that you multiply whatever's inside by that number, right? So, and you only do that when it's like a compound in itself. So this is aluminum sulfate. So, okay, pretty good so far. You understand that? Not too bad. Yes, no, maybe.
Yeah.
Okay.
It'd be sulfate 3 with oxygen 4, or with 4 oxygen.
So it's sulfate. So this is called, this whole thing together, what's inside of here is called sulfate.
Yeah.
Yeah. So, but you would just call it aluminum sulfate. You wouldn't have to tell me because it has a charge associated with it. And anytime that there's no charges up here, right, then that means that it's neutralized itself. So there's no charges up here. So these guys are going to neutralize them. And we'll talk about what those charges are, how you determine those charges, because we have to talk about it briefly, but not in much detail.
Okay.
Okay. I promise you. Okay. Okay, but I just wanted to get you guys familiar with the periodic table so that, let's say you don't know what the symbols mean, because you're going to see symbols quite a bit, particularly since we're talking about chemicals. Basically, everything that we're working on, if it's a protein, it's really a chemical as well, too. Can't get away from chemistry. We eat it every day. Okay, so let's see. Okay, so most abundant oxygen, carbon, hydrogen, nitrogen, calcium. So you want to be familiar with those elements. So when I ask you on the test, what is the most abundant molecule in your body?
Oxygen.
Oxygen.
Oxygen. Especially if I give you the table. If you can't read the table, you won't be able to tell, right? So you want to make sure that you're able to read tables as well, because you may end up getting a table like this and saying, so what are some of the trace elements in your body?
What is the what?
Trace elements.
Trace elements?
Trace elements. Yeah.
Copper.
Copper. Yeah.
Iodine.
Okay. Okay, so let's talk a little bit more about the atom, right? So the atom is basically made up of protons, neutrons, and electrons. So in the center of the atom, we have what we call the nucleus. The nucleus contains your protons and your neutrons. Okay, protons are positively charged. Neutrons are neutral. So they have no charge associated with them. Electrons are on the outside of the nucleus, right? They form what is called a cloud. So they're kind of cloudy-like, circling the nucleus. So it's kind of like a planet. So this is our cloud of electrons. Okay, so helium, let's go back to the periodic table. Come on now. Helium is right here. Okay, so this number here is called the atomic number. The atomic number is the number, it lets us know the number of protons that a element has. Okay, so helium has how many protons?
2.
2.
Palladium has how many protons?
The what? Sorry?
Palladium.
Palladium.
Gallium.
Oh, palladium.
Palladium.
It
Can you find it? What is the symbol for palladium? Gallium.
Oh, 31?
Nope, that's right. It has 31. Okay.
oh,
So it has 31 protons. Now, every element, unless it's an ion, and we'll talk about what an ion is, every element, unless it's an ion, is going to have equal amounts of electrons that they have protons, because they have to balance each other out. It has to have a total of a 0 charge. Because remember, electrons are negatively charged. And protons are positively. Okay, so how many electrons does beryllium have? Beryllium, Beryllium, beryllium.
4.
4. Okay, so beryllium has 4 electrons. It also has how many protons?
4.
Okay, so let me tell you how to figure out how many neutrons it has. Okay, so the easiest way to figure out the number of neutrons it has is by looking at what we call the atomic mass. We'll use beryllium as our example. This here is the atomic mass. Now, the atomic mass is, if you notice, it's like 9.01222, right? So when you're trying to calculate the number of neutrons, you want to round it to the nearest number. So we'd say 9, right? The atomic mass is 9. So that would be called our mass number, since we rounded that to a whole number. So the way that we calculate our number of neutrons is protons, I'll put P for protons, plus neutrons equal our atomic mass, our mass number. Okay, now we're talking about beryllium. How many protons does beryllium have?
4.
4 plus N equals 9. So can we solve for N?
5.
N equals 5. So beryllium has 5 neutrons. Fix my plus there. Okay. Hydrogen. Let's do hydrogen.
1.
Okay. So hydrogen, it has 1 proton. Okay, so 1 proton. How many electrons does it have?
1.
1 electron. Okay, and then how many neutrons? How would I calculate the number of neutrons?
So you would do like 1 for the number of protons plus n equals, and then the atomic mass was, I would call that 1. So
That's
it
right.
would have 0 neutron?
That's right.
Trick question.
Okay, one more. You want to try one more, or do you guys, you're feeling confident? You're like, ah, I got this. I don't need to hold my hand for it. One
Let's just do one more.
more. Okay, so let's do carbon.
Okay.
6.
Okay. So how many protons does it have?
6.
6. 6 protons. How many neutrons?
6.
And how many electrons?
6.
Okay. Piece of cake?
Yeah.
Yeah.
Okay, good. Any questions before we move on? Or forever hold your peace.
Mm-mm.
Okay, so we've talked about the periodic table. Isotopes. Okay, so let me explain to you what isotopes are. So an isotope is an isotope of an element is the element has the same number of protons. Protons would be exactly the same, but they have a different number of neutrons, which means that you're going to have a different mass. Like, so for instance, these are all isotopes of hydrogen. So this is called, the first isotope of hydrogen is called protium. Deuterium is the other isotope of hydrogen, and tritium. Okay, so protium, this guy has 1 proton, it has 0 neutrons, and it has 1 electron. So that's an electron, no neutrons, and this represents the proton. Deuterium has 1 proton, 1 neutron, and 1 electron. Okay, so this guy, if you guys remember, this is what we just basically call hydrogen, right? Because it represents the most amount of the hydrogen, right? So this guy would weigh how much? What would be its mass? How did I calculate the mass? Or
Protons plus neutrons.
it's protons plus neutrons.
So it would just be 1.
So in this case, this guy would just be 1. What about this guy?
2.
2.
That's right. So 1 plus 1. And then what about this guy? one. This is one neutron. This is a second neutron. This has two neutrons. They should have made them both purple.
Yeah. So it'd be 3.
So it would be 3. So it would be 1 plus 2. So that would equal 3. So when we talk about isotopes, we write the element. The number up here, this represents the mass number. Okay, so that guy right there is the mass number. So that tells me how much it weighs, right? So by knowing what the new mass of it, we can sit there and determine how many neutrons it is, and we can determine whether it's an isotope. Okay, are you with me?
Yeah.
Okay, so you're saying, why the hell do I need to know about isotopes? God, all this stuff, do I really need this stuff, right? So, as a matter of fact, you do, because we use isotopes to sit there and do various tests. Like, for instance, have you guys, anybody had tests done to test out their metabolism, whether your metabolism is functioning correctly? Anybody done that?
No.
Nobody. What about anybody have done anything with sonograms? Did anybody have a sonogram and they make you drink all of this milky substance? Or
Yeah,
cat-
I've had to drink that before. Mhm.
Okay, so those things actually have isotopes, and a lot of them are not deadly to us. They can be if it's the wrong isotope. So they allow us to do imaging. And so we can use those isotopes to sit there and image things. So sometimes it can be used to identify like cancerous cells, or you can use to sit there and determine whether or not your metabolism is functioning correctly by using those different isotopes. So that's the reason why isotopes play a part in the health sciences, is we use those tools, we use them as tools in our industry. So, questions, concerns, Ash? Okay, so I think I'm gonna stop here and then we'll start back here on Tuesday or Monday. Is that cool?
Yep.
So remember, we stopped at PET scan. We're just gonna talk about how that works. Okay,
Okay,
so
sounds
I
good.
will see you guys, since you guys are gonna get another pass on this damn lab. Eventually it's gonna work out. Don't know how, but we'll figure it out. So I will see you guys on maybe tomorrow during the thing. Boy, this class is tiny. Are there any questions?
Yeah, I had a question about the lab kit pickup.
Yep.
So since we're at since our schooling is for Kalinga, can we go to Lemoore and Fireball to pick it up, or do we have to go to Kalinga?
No, you can go anywhere. That's why I'm going to all of the 3 different spots.
Oh, okay, perfect. Thank you.
No problem. Any other questions?
The 27th is the day that you're coming to Lemoore, right?
That is right. I'm coming there the 27th. I'm also coming to NDC or Fireball on the 27th, but I'm also coming to Kalinga on the 27th. It'll be 2 hours at each.
What time you gonna be in Lemoore?
Let me pull that up so I'll tell you the truth and not lie to you.
It's on Canvas, right?
Yep, it is on Canvas. Let me, and tell me if you don't see it. If you don't see it, let me know. Actually, I'll put it in modules so that you guys should be able to see it. Make sure it's there.
So for this week, we're only gonna have the syllabus quiz and the reading chapters that we're supposed to read for homework.
Yep. Yeah, it's already under modules. So it's under Bio35 kit pickup. Okay, so let me share my screen. You guys can't see anything, can you? Can you see it now?
Yeah.
Okay, so it will be 10 a.m. to 12 p.m. in Fireball. And then it'll be 1:30 to 3:30 p.m. In Kalinga, and then 4:30 to 6:30 p.m. in Lemoore. Okay, so you guys know where Circle Drive is? You guys know where the library's at? So that little loop, that bus loop in front of the student service building. So that's Circle Drive. And it's between, I'm gonna be between in the parking lot in front of G and H in Kalinga. And then for Fireball, it'll be right in front of the front entrance. Okay?
Okay.
Okay. So all you guys need to do is just kind of pull up, and then we'll hand the kits to you. You don't have to get out your car or anything like that. So we'll hand you your kids. So
Mm,
okay.
okay.
Any other questions?
No.
Okay. So you guys will have to buy on these labs. I'll try to get it worked out, the problems. Hopefully today I'll send another message and hopefully somebody will respond. So I will see you guys next week or at the keynote speaker tomorrow for extra credit points.
Perfect. Thank you so much.
Okay.
Can't
Okay,
wait
have
for
a
my
good day.
extra credit.
Thank you.